INREP toward indium-free TCOs. INREP is a 3-year Horizon 2020 collaborative research project with the objective to develop and deploy valid and robust alternatives to indium-based transparent conductive electrode materials in applications such as high-efficiency solar cells, gallium nitride LEDs, organic LEDs and touchscreen monitors. INREP gathers 13 partners from 7 countries and involves 30 researchers and engineers. Indium-based materials, mainly indium tin oxide, are technologically entrenched in the commercial manufacture of components like LEDs, both organic and inorganic, solar cells and touchscreens. The combined size of these markets has multiplied by a factor of 4 in 5 years, creating a large and growing demand for indium. This has fueled a 350% increase in world production, with the price of indium increasing by up to 800% between the year 2000 and 2010. INREP brings together a unique multidisciplinary consortium to meet a double challenge, namely the creation of transparent conducting oxides, TCOs for short, and their deposition technologies with the optimum optoelectrical properties for the cost-effective and safe manufacture of optoelectronic components. INREP's main outcomes will be the development of indium-free electrode materials for high-efficiency PV applications, the development of advanced techniques for depositing these materials, including an advanced form of atomic layer deposition, ALD for short, as well as equipment for low-damage sputter deposition based on innovative proprietary technology. The development of indium-free TCO contacts for large-area LEDs, and finally, life cycle assessments of the environmental impact of the new materials, as well as analyses of the cost of ownership. Achieving these outcomes will require complete assessments of the relevant properties of the proposed TCOs, including the impact of deposition technique, and, by doing so, devise optimum processes for their application in selected high-value application areas, such as high-efficiency solar cells, gallium nitride-based LEDs, organic LEDs, and touchscreen monitors. Also required will be related equipment developments that will achieve upscaled, low-damage manufacturing processes that will cut costs. Life cycle assessment, LCA, to ensure that the products that incorporate the indium-free TCOs are environmentally safe to manufacture, use, and dispose of at the end of their useful lifetime. Finally, cost of ownership analyses of the formation and use of TCOs over the entire period, from their application in manufacturing through component operation and into waste management. For use in high-efficiency PV cells, the developed indium-free TCO films should have charge carrier concentrations in the range of 10 to the 19 to 10 to the 20 per cubic centimetre, with an electronic mobility greater than 20 square centimetres per volt per second, to enable its dual use as a front and back electrode in advanced silicon heterojunction solar cells. For application to organic LEDs, OLEDs, the developed indium-free TCOs should have a sheet resistance below 10 ohms per square and visible absorption below 5%. Thin films of the TCO materials should have a sufficient surface film roughness for the OLED leakage current to be below 10 to the power of minus 3 milliamps per square centimetre without detriment to the cost of ownership. Applications of the novel indium-free TCOs to gallium nitride-based LEDs will require establishing conformal TCO coating processes, with the potential to uniformly coat high aspect ratio nanostructures without detriment to the cost of ownership. The TCOs should have a sheet resistivity below 5 times 10 to the power of minus 4 ohm centimetres, a transparency of above 88%, and a contact resistance below 2 times 10 to the power of minus 5 ohm centimetres for large area planar LEDs and LEDs. For application in touchscreen displays, the developed indium-free transparent electrodes should have a sheet resistance below 100 ohms per square and a transparency higher than 90% in the visible part of the spectrum. The haze factor should be below 2%, again without detriment to the cost of ownership. The ambition of the 13 partners of the INREP consortium is to develop a European value chain that will support and exploit emerging indium-free TCO technologies in economically important products like OLEDs, LEDs, solar cell and touchscreen displays. The consortium comprises leading research establishments, universities and renowned companies, including equipment manufacturers and end users, working together to develop this value chain with the goal of creating economically viable indium-free TCOs and deposition technologies suitable for a wide range of distinctive products and manufacturing processes. Toward Indium-Free TCOs is a research and innovation action running from February 1st, 2015 to the 31st of January 2018, and with a total budget of €6,197,150 and the total manpower of 590 person-months. Dimitrios Biliouris is the INREP project advisor from the European Commission. The coordination team is composed of Duncan Alsop from the University of Bath and Sylvain Nicolet from CSEM. This project has received funding from the EU Horizon 2020 Research and Innovation Programme under Grant Agreement number 641864. We invite you to consult our website at www.inrep.eu and our social media applications.